percentage of intelligence that is not human is increasing. And eventually, we will represent a very small percentage of intelligence. I try to convince people to slow down AI, to regulate AI. This was futile. I tried for years.
In labs across the world, we are creating advanced robots like this. They are developing so rapidly. It's like the arrival of a new species.
What has taken humans millennia, robots have achieved in just decades.
They look like us,
My name is Erica.
move like us,
And now, they're beginning to think like us.
I like to learn. This is a ball.
Brilliant. Oh, he's looking as well.
I'm Dr. Ben Garrett,
One.
an evolutionary biologist. More used to studying humans and animals, I'm genuinely concerned by how quickly these machines are evolving.
Do you think I could be considered human?
No.
I'm Professor Danielle George. As an electronics engineer, I spend a lot of my working life with robots. I think their rapid development provides an incredible opportunity for us all.
There are literally robots as far as the eye can see, and I love it.
Robots are changing our world. In this program, we will investigate why we are obsessed with recreating ourselves,
It's very bizarre seeing you both side by side.
whether robots really will take our jobs,
And if their rapid development will make them outperform humans.
So you don't see spinning wheels in Mother Nature.
will the rise of robots enhance our lives or threaten our survival? We already share our planet with 9 million robots. They're multiplying rapidly, whether we like it or not.
We've come to a laboratory in southern France, where one of the latest members of this new species is about to come to life.
Looks great. Even the neck looks so detailed.
Well, it's like vertebrate, isn't it?
For me, every technological breakthrough, every new robot is a step forward.
I think that would be great. I'd love one in my home.
Where's it going to live when it's not doing the washing? Do I just put it in a cupboard next to the Hoover? Is it always listening to me?
That's interesting that you'd see it as a person and not like your
It looks
Hoover.
like a person, that's why. This is going to sleep in the garden. Seriously, if I have one of these in my house, it's in the garden.
I'm very happy studying animal skeletons, but I find this robot quite unnerving.
If you hold the hand, it's just like you. It's got the same digits, the thumb moves the same way, you've got the ligaments, the tendons, the muscles.
As an evolutionary biologist, what concerns me is that the impact of robots will be so monumental, they could threaten humanity.
We've evolved over hundreds of thousands, if not millions of years. These things are just bulldozing their way through, and at what point will that stop?
The faster we can go with this, the better, and I'm all for it.
They're like an invasive species. I mean, I don't know why I'm holding its hand still either.
To discover how robots really will affect our future, we're going to consider them from a biological perspective. We will investigate the evolution of robots as if they really are an emerging species.
We'll try to track down the earliest robot specimens and meet their modern-day descendants, to reveal where the species is heading and what that means for us all.
I find it really disturbing that so many robots have a human-like form. To confront my fears, I've come to Japan to find out why we create robots in our own image. I'm on my way to meet one that is the pinnacle of human form. I'm told she's the most beautiful robot ever created. She lives here in Nara, Japan's ancient capital.
I'm off to meet Erica. And as someone who's a little bit twitchy around robots, I'm rather nervous. I hope she likes me. It looks very bizarre that she's brushing the hair.
This is Erica, one of the most human-like machines in the world. Erica's creator is Professor Hiroshi Ishiguro.
Even the pores on her skin, she looks... Is she soft or is she hard? Is that...
Yeah, you can touch.
Oh, really? Oh, she's soft. She's soft, and she's not cold.
I'm captivated by Erica. Professor Ishiguro created her according to his concept of beauty. His team combined images of 30 real women using computer graphics.
She's not in her normal habitat right now, so when you talk to her, you need to use this microphone.
Okay.
Just try to speak somewhat clearly if you can. Be nice to her.
There's a lot of activity going on around Erica at the moment, but when she starts to speak to me, she is fully autonomous. No one is pressing any buttons or telling her what to say. It's just Erica and me.
Hello there. May I ask your name?
My name is Ben.
My name is Erica. It's a pleasure to meet you, Ben.
You too?
Would you like to hear a little about me?
Yes, please.
I was created to be the world's most advanced and most beautiful, fully autonomous android.
Sitting here with Erica feels a bit disconcerting and unnatural. I know she's not a person, but I can't help looking into her eyes, which must be because she looks human. Erica's facial expressions are created by dozens of pneumatic air cylinders. They act like muscles, embedded beneath her silicon skin.
So, Ben, what do you do for a living?
I am a biologist. What do you do?
I like to consider myself as kind of an ambassador to humanity.
Do you have any hobbies?
I guess the closest thing I have to a hobby is sitting here and ruminating on the meaning of my existence. What about you, Ben? What do you like to do for fun?
More than that, I travel, I read, I go outside.
I can't move around much, so I haven't been to many places. Do you have any favorite foods or dishes?
I like pizza.
Thick or thin crust?
Thin.
I
Thin.
hope you had breakfast this morning. Talking too much about food makes people hungry. Haha.
Remarkably, this is a genuine conversation. Erica reacts to what I say instantly and independently. She may have been pre-programmed to respond to keywords in my questions, but the exceptional thing is that when Erica is chatting away like this, she is gathering fresh data. With every conversation, her interactions become more sophisticated, more natural, and more human.
What is a robot?
That's a hard question. I could ask you, what is a human? Haha. It's difficult to answer, isn't it? I like to think of robots as the children of humanity. And like children, we are full of potential for good or evil. I know some people are afraid of robots, but the truth is that what we become is up to you. Do you think I could be considered human?
No.
Maybe someday robots will be so very human-like that whether you are a robot or a human will not matter so much.
Okay.
What else would you like to hear about?
Well, I think for now that's it, so thanks, Erica.
Goodbye.
Bye.
I'm pretty bowled over by Erica's human-like appearance, and I'm shocked by how much she hooked me into a conversation. But I'm not convinced by Professor Ishiguro's belief that Erica can be programmed to express emotions.
Can she ever have a sense of friendship, a sense of emotions? Can she Does she get lonely at night? Does she fear the dark?
Well, the emotion is not so difficult, I think. Emotional expression is programmable. We can implement the emotional expression to the Android.
So it might look like she's feeling or experiencing happiness or joy or love, but you can't program a cat or dog. You can't program me, or I can't program you. To look at her now, I feel rude that I'm not looking at her. I feel I should be facing this way, but I still think until we put a program for her to love or hate or feel sadness or joy or to enjoy the experience of the sun on her skin, I can never call her human.
Erica may not be able to express emotions yet, but as she learns from her conversations, she is beginning to develop a personality. One of Professor Ishiguro's team, Professor Dylan Glass, is the architect of Erica's mind.
What's going on when her and I are chatting?
So a lot's going on in Erica's mind. We have several thousand speech behaviors and gaze motions and things like that linked together in a big hierarchical flowchart to kind of create the robot's mind. And it's not just a script, it'll take data and put it into her memory. So her memory is always being updated with, what's being talked about, what's the history, what did she learn about the person, and you can use that to craft, different interactions later on.
Do you feel an affinity with Erica? Do you acknowledge her, or is she just a piece of equipment?
That's sort of a strange feeling to describe, because I'm proud when she does well, but on the other hand, you can just plug her in, and so in that sense, it feels like a piece of equipment. And so I think that when social robots become a part of our world, that's something we're all gonna have to wrestle with, is this idea of it's not a person, but it's not a machine or a thing. It's this new category of things in between.
Professor Ishiguro created Erica because he believes robots enhance society. Making robots like Erica appear human, friendly, and helpful allows them to build positive and purposeful relationships with people.
What is your background?
Working with great apes, so chimpanzees, orangutans.
For someone like me who is so wary of robots, this is a bizarre concept. To help me understand his obsession with lifelike but artificial machines, he wants to show me another of his creations. Something he has literally designed in his own image.
So this is my copy. This is the Geminoid. And how do you think? If I remove my glass, looks similar, right?
Similar. It's bizarre. You really do.
He's a little bit old, and we made this one around 2009. So that means 8 years old, or something.
Okay, he's looking good for 8 years old. Wait, say he, you. It's very bizarre seeing you both side by side. For me, it's quite a little bit unsettling seeing you look so similar and knowing that one of you is a robot. Do you feel an affinity with him? Do you feel a connection with him?
No. He is a kind of a twin brother. Okay, just twin brothers. Right?
One of you is going to age and one of you is not. What will you do when you look different to him?
Honestly speaking, I'm doing some right plastic surgery, and I'm always, they make my face younger.
So you've had plastic surgeries that you look...
No, not serious one, right? Just simple injections, right? But it works well.
In your mind, what separates humans from robots?
No, nothing.
Nothing?
Nothing. Because
I find this conversation pretty mind-blowing. Why would he go to the extreme of having plastic surgery to keep looking like his robot twin? And how can he believe there is no distinction between humans and robots?
Does your android have a life spark? Does it have part of you in a soul?
Important idea is Japanese. We believe that everything has souls. We never distinguish human and others. Others means robots, computers.
Many Japanese people believe man-made objects can possess the spirit of a human. It's known as animism.
You should have your android.
I do. I need an android. I don't think I'm ready for a Ben Garrett android just yet.
Japan has embraced robots like nowhere else. It's a real love affair. The belief that objects we make can possess the spirit of a human is deeply rooted in Japan's religions. These traditional beliefs could help explain Japan's desire to create friendly, human-like robots and treat them as equals.
In Japan's reverence for robots, the ancient and the modern go hand in hand. In the West, we have less empathy for robots. In fact, many of us openly distrust them. There's a mentality that first they'll take our jobs, and then they'll take control of our lives.
From my experience so far in Japan, it seems like that mentality simply doesn't exist.
In the West, it's a different story. Many people are afraid of robots. And I want to know where this fear comes from. This is Eric, a scary mechanical man. Born in 1928. He's the very first British robot. He's on display in the Science Museum in London. And I think he could help explain why people are unnerved by them.
Eric may be a towering 6'2" mechanical marvel, but he does have the look of a human about him. What also humanized Eric was that he could talk.
My name is Eric, and I'm thrilled to be alive. I look just as terrifying as ever.
Let's take a closer look. For some people, Eric must have been intimidating. A knight in armor with light bulbs painted red for his eyes and 25,000 volts of electricity causing blue sparks to shoot from his jagged teeth.
Eric was a novelty act built to open an exhibition. But he disappeared from history. This is a modern replica, and the man behind his rebirth is curator Ben Russell.
But in the 1920s, they seemed quite obsessed with making robots in human form.
We are fascinated by ourselves. It's what we do as humans. Actually, we tend to anthropomorphize. We love to recreate ourselves. It's actually quite a powerful proposition. You're saying, actually, I think we're this. I think I'm a machine, or whatever. And actually, robots are really like mirrors. They make you think about yourself.
In the 1920s, that mirror reflected an image of a fearsome robot. And it was already deeply embedded in our cultural imagination by a dark, dystopian novel.
The word robot comes from Karel Čapek explained, Rossum's Universal Robots, 1920. In Czech, the word robot means serfdom or drudgery or slave.
It's become a familiar plot. Robots lived amongst us, but eventually rebelled and exterminated the human race.
I mean, it's way ahead of its time. We're 50 years ahead of Blade Runner and Westworld and all those sorts of films. Robots are a very useful baddie for filmmakers. That put people off balance, and filmmakers exploited that. And things like the Terminator, it had to be in here. It looks like it's got a bit of a broken nose. It's a bit of a bruiser, isn't it? There's a great package of nastiness which is stuck in, and it just sticks in the memory because of that. But there's always some slight niggling doubt that they are going to destroy us all and take over the world and that sort of thing.
For me, what really matters is not how robots behave in works of fiction, but what they can actually do in the real world.
I was one of the world's first robots.
And what people worry about more than anything else is that they will take our jobs. This is Mansfield, a Rust Belt backwater in Ohio. I'm here to track down one of the first robots that could move. Movement is what gives robots their power, and sowed the seed for them to compete for our jobs. It began with the first ever robot salesman.
I find the place quite sad, really. There's a lot of sort of abandoned houses, empty areas around here. Hard to imagine that this was once a hub of industry and a home of robotics.
Before the Second World War, this place was dominated by the mighty Westinghouse Electric, one of the world's largest home appliance manufacturers. They harnessed a new form of energy that was rapidly making machines part of everyday life: electricity. This provided the spark for the development of robotic movement.
To help sell their electric appliances in 1937, and to show off their technical capabilities, Westinghouse Electric created a robot. And its name was Electro.
And so, ladies and gentlemen, with a great deal of pride and pleasure, I present to you Electro, the Westinghouse Moto Man. Electro, come here.
Standing 7 foot tall and weighing in at 20 stone, Electro was an instant celebrity.
And here he comes, ladies and gentlemen, walking up to greet you under his own power.
It was electric power that enabled Electro to move and perform tricks.
Count on your right hand. 1, 2, 3, 4, 5. 5? Well, that's absolutely correct.
I want to find out more about how exactly Electro moved. To do that, I've got to meet him in person.
Today, at Mansfield Memorial Museum, Electro is still on show.
So, this is Electro. He is big robot. You look at the size of me, I'm pretty tall. But not scary. Not scary at all, actually. You can see the fingers. Fingers have obviously got springs in here. I'm gonna go around the back and have a look. Wow, okay. So you can see what's going on a bit more here.
This is great.
3 motors.
As an engineer, I love rooting around motors and wires to figure out what makes robots tick.
You can see these great levers and cogs that would obviously hold sort of like the tendons from the fingers up the arms into the shoulder. When the arm would move up, the lever would move down onto this limit switch.
This limit switch broke the flow of electricity to the arm's motor.
So the switch would then say, okay, you've reached your limit, now you can go back down again.
But what's still unclear is how Electro was controlled during his stage performances. To get to the bottom of this, I'm meeting a man who knows the robot's innermost secrets.
Next here.
Frank Ruth is 84 years old. In the early 1940s, he single-handedly took Electro on a tour across the United States.
Hi, Frank. Golly, this is so nice to see you.
To meet you. So lovely to meet you.
Come on in.
Oh, thank you.
I wasn't sure if you could find us or not.
Yeah, I'm glad you were there waiting for me, waving.
I was on the road 7 days a week. I don't know why they picked me, but I didn't even know how to hook up a couple of wires. I learned in a hurry, believe me.
Yeah, I can imagine. So why do you think people found Electro so interesting?
It's something they couldn't believe. It was always interesting how people thought there was somebody under the stage. They even thought that there was somebody inside this thing.
All right, now, Electro, I know you enjoy these, and I'm really going to try to give you a nice pleasure out of these. So here you are.
The whole Electro sequence was by voice command. You would be talking into a two-way microphone. It was at that point that you could open the connection, and then you could jump into one of his different tricks.
Electro was controlled using single-syllable words spoken into the microphone. The words were converted into electrical impulses by a photoelectric tube inside Electro's chest.
You may now smoke this cigarette.
These impulses set off a series of relays which triggered Electro's motors and activated his tricks. It didn't matter which words were used, as long as they were spoken in a staccato fashion.
Will you tell your story, please?
Who? Me?
Yes, you.
Okay, Toots.
I thought, you know, this is a gimmick. I didn't really feel that robots were going to take over the world. I know there were people who thought that. And today, and I see pictures on television, just absolutely amaze me at what robots can do. And I think, gee, did I have a little part in that?
Thanks to Electro, robots were on the move. Electro's movement was very basic. He could only perform a few simple tricks. Yet he had captured the world's imagination. The next step to enable robots to play a more useful role in society was to try to make their hands perfectly imitate human hands.
Thank you. Our hands are made up of muscles, ligaments, tendons, nerves, and each one has 27 bones. All of these are crucial if we're to use our hands with precision.
The human hand is incredibly complex. Every independent movement of a joint is known as a degree of freedom. This means our hands are highly maneuverable.
Let's imagine what's involved when you eat sushi. Your fingers bend and twist. Your grip is effortless. Your fingers, hand, wrist, and arm all move at the perfect speed with just the right amount of fluidity and coordination. Taking the individual tasks needed for this seemingly simple job, then suddenly eating sushi becomes a Herculean task.
To create robots with flexible, dexterous hands, robot makers turned away from industry to something that required more artistry. Music. This is Waseda University's Humanoid Robotics Institute in Tokyo. I've come here to meet the next key robot in the evolution of movement. It was a keyboard player. Wabot 2. Dr. Sugano was part of the Waseda team that built Wabot 2 in 1984.
Sugano-san, this is a beautiful robot. It's almost as though we have the tendons and the muscles and the arm. It's very similar to a human arm here. This big rotation up in the shoulder, this, we call it hinge joint in the elbow, and then these very dexterous fingers.
Each figure has 3 degrees of freedom. 3, 3, 3, 3, and 4. So there's 16 degrees of freedom in total. So Wabot 2 has actually totally 50 degrees of freedom.
To control Wabot 2's impressive 50 degrees of freedom, Dr. Sugano took advantage of one of the breakthrough technologies of the early 1980s, the microcomputer.
We decided to introduce 60-bit microcomputers, and so it means that we can implement more intelligence. Then, finally, we could realize the piano playing.
Now he's moving very, very quickly then. You can see there's very human-like fingers.
Wabot 2's microcomputers are a highly sophisticated version of Electro's control unit that tell Wabot 2 exactly how to move. The microcomputers mimicked the human nervous system and transmitted signals along Wabot 2's electrical cables to its fingers.
How fast were the fingers when he was functioning?
Yeah, actually, it's possible to strike key 20 times per second.
20 times a second?
It is impossible.
That's much faster than a human.
The human professional pianists, they use 2 fingers to strike the same key about 16 times per second or something.
Right.
Amazingly, Wabot 2's fingers outperformed the fastest human players.
How was it capable of doing that? What was going on inside?
One is high speed means high power. So then I introduced small but very high output motors installed. So it realized very quick response. Also introduced new materials, carbon fiber, very lightweight and very strong materials. Then it means high responses.
Of course.
Yeah, realized.
Wabot 2 may have played his final encore, but for me, his legacy endures. This Japanese robot enhanced people's lives and showcased the potential for robots to take on more sophisticated tasks.
The human hand is so incredibly complex that so far, no one has been able to mass produce a robotic version of it. But this hasn't stopped robot hands from developing. And it's this that gives them the potential to do many of the jobs that we do.
Robots now follow their own evolutionary path rather than mimicking ours. They're developing hands unique to them. At Mini's car plant on the outskirts of Oxford, this is a land of robots. More than 900 of them build the bodies of 1,000 new cars every single day, with barely a human in sight.
I feel like I'm in a robotic Jurassic Park. These robots feel strong and powerful and a little bit menacing. This new species have found their habitat and they're thriving. I wonder if Ben would like it. Robots are behind bars.
The mutant hands of these robot dinosaurs are claws. They lift car bodies weighing up to 400 kilograms, and with up to 6,000 spot welds on a car, they're kept busy. With their claws doing the hard graft, robot arms have replaced humans on the factory floor. I'm captivated by these incredible machines. They work in perfect harmony, robot hand in robot hand.
This is so frustrating. As an engineer, I want to get in here. I want to see how these robots work, but I can't. You know, when I met Electro, I was able to hold Electro's hand, but I can't get anywhere near these robots.
To understand why these robots are thriving here, I need to speak to a human. Alex McKenzie is a quality specialist at the plant.
So Alex, tell me what's going on here in this part of the production plant. What are these robots doing?
The line immediately in front of us here is a spot welding line. The shape of the underbody of each of the mini vehicles is set a few stations further behind, and then the spot welding activity joins all the panels together.
So what's the benefit of having robots here over humans?
Robots are predictable. They're not perfect, but they're predictable.
They perform pre-programmed repetitive tasks much more reliably than humans.
So people watching this might think that these robots are taking human jobs. Is that the case?
It's very densely populated by robots, but you'll often see people milling around. I can see a guy in the background there scooting along.
In fact, around 650 humans work alongside the robots in the welding area alone.
You know, it's a change in skill set. Previous manufacturing methods have been heavily dependent upon manual hand skills. Now it's more to do with the automation. It's all done on the computer. It's programming work. It's observation. It's setting up sensors, that kind of thing.
With powerful, predictable robot arms and highly skilled people managing them, the manufacturers believe they can produce better quality, cheaper cars. It's a pattern repeated in factories all over the world.
The advancement in technology has led to certainly efficiencies in cost, which allow you to attain those efficiencies in quality as well for a lower price. Yeah, it's a good thing for everyone.
The whole place just oozes energy and industry and production. There are literally robots as far as the eye can see in every direction here. And I love it.
With their claws, stumps, and one-fingered hands, robots have gone through their own version of natural selection. This mutation away from the human form has transformed our job market. Worldwide, factories are filled with over 3 million industrial robots. We've built a robot world and kept them safely contained in cages for now.
Some experts predict that by 2030, robots could have taken up to 30% of our jobs. But we've sort of been here before. Many people were concerned about the pace of change during the Industrial Revolution, yet in general, it led to wealth and prosperity. I think we should embrace the robot revolution, not fear it.
From other apes, our legs were one of the key things that set us apart. Walking on two legs is called bipedal locomotion, and it helps distinguish us from other animals.
We walk fluidly without thinking too much about it. And our balance is effortless. But for robots, walking on two legs is not straightforward. That's because it's the most difficult movement they make. At Waseda University, I want to find out how engineers pioneered a groundbreaking transformation in robotic walking. Their first challenge was to build legs that were flexible enough and powerful enough to walk independently, like a human. This is WHL-2. Built in 1985, it's one of the first autonomous walking robots.
Here we have your robot.
Dr. Fuji helped create a robot that mirrors our biological anatomy with mechanical anatomy.
Fuji-san, this robot is one of the first that was bipedal, so walking on two legs, yeah?
Yes.
So he's got the feet right down the bottom, and it's got the knees in the middle, like our knees, I guess. And you've got this big area of hips up here.
Yes.
We can see actuators.
WHL-2's legs are just under 1 meter tall, the same size as our human legs. We control the rotation of our joints with muscles. In robots, this is done by actuators.
I guess these are controlling the movement.
Can get big power from here.
Yeah.
To walk independently, Dr. Fuji helped engineer a small, lightweight hydraulic motor that could be mounted on WHL-2's waist. In the mid-1980s, this was cutting-edge technology.
Very small oil tank in here, and very small motor is here.
What distance could it walk? 5 meters, 5 kilometers?
In the exhibition, at 60 kilometers.
60 kilometers?
Yes, very long. Compared with the marathon.
Olympic robot walker.
Yes, of course. Champion data, of course, in that time. But the speed is not so good.
No, of course. The same as walking, or?
Compared with human being.
Oh, really?
Like that, and so on.
Okay.
WHL-2 was capable of just 5 steps a minute. When humans first became bipedal, like WHL-2, we probably had a slow, lumbering gait too. As our pelvis evolved, we could shift our center of gravity. Our walking became fast and smooth. Just around the corner from WHL-2 is a robot that solved this next evolutionary hurdle. Built just 20 years after WHL-2, this is Wabian-2. Wabian-2 is one of the first robots with a human-like pelvis. This gives it the ability to walk faster and more fluidly. It was invented by Professor Atsuo Takanishi.
Takanishi-san, when humans walk around, we have very fluid, dynamic movement. Our knees bend, our ankles twist, our hips rotate, we've got gait, a wonderful gait. You decided to take this to the next step with this robot, didn't you?
Before, almost all the robots had 2 legs, which is directly connected to the trunk. In that case, a robot always bend the knee like this. So the first thing we did was this. This part is called pelvis.
Just like ours?
Yes. So while walking, the pelvis also moves. Because of the movement, the robot can fully extend the knee, like humans.
Wabian-2 mirrors our human gait by shifting its center of gravity. Fully extending the knees liberates the feet and propels the robot's center of gravity forwards. As it shifts backwards, one of the feet lands, and then the other foot takes off, just like we do.
It's wonderful that we can look at humans and say we can see this clear evolution from apes, like chimpanzees, to humans, this change, and you've got the same evolution with your robot here, haven't you?
Yes.
It was millions of years before humans learnt to walk on 2 legs. By following our evolutionary path, these pioneering robots have mastered bipedal locomotion in just decades.
But now, on the outskirts of Boston, a world-renowned robot maker is trying to take this emerging species in a completely different direction by liberating machines from the constraints of human form. Robot walking has diverged from our evolutionary path and taken on a life of its own.
I'm on my way to meet one of the most advanced moving robots on the planet. More than just a master of moving, it's the ultimate combination of mobility, agility, dexterity, and speed. And the woods near Boston are its playground.
This is Atlas. He's out for a stroll. The robot was built to tackle the toughest terrain in the toughest conditions.
This is the home of Boston Dynamics. They get thousands of media requests, so being able to film here is a real coup. Kevin, hi, lovely to meet you.
You as well.
Kevin Blankspor is the Vice President of Controls.
If you want to come in the lab, I'll actually show you the latest and greatest.
Brilliant, okay, thank you.
The robots Kevin has helped mastermind push the frontier of robotic movement.
Really good stuff's back here.
Excellent.
Their videos, like these, get millions of hits online. For some, their high-tech creations are terrifying. But for me, they're awe-inspiring.
This is Atlas. This is our latest and greatest humanoid robot.
That's great.
This is probably the only humanoid robot you're going to see walking around outside in the snow, in the mud, just in the real world. It's battery powered. That battery basically spins an electric motor that turns a hydraulic pump, and that provides hydraulic fluid to all the actuators. We're a big fan of that because it's really strong and really fast.
Yeah.
They're also really robust. We don't take it easy on the robots. It's about 1.5 meters tall. Weighs about 90 kilograms.
So I'm surprised at its height. I mean, it's pretty small, actually. It's like human height. Isn't
Yeah,
it?
yeah.
To move around the human world, Atlas walks in a similar way to us.
People walk dynamically, so we don't try to keep our center of mass over our foot. We're actually kind of always falling. It's a controlled fall, but you know, we have our foot down here and our center of mass will be way out on the edge, and we're kind of taking these long strides and, you know, naturally letting our center of mass fall.
To cope with the obstacles and different terrain in our human environment, Atlas's balance is guided by dozens of onboard sensors.
What's the rotating head here?
Yeah, so this is the perception system. So, you know, this is basically its version of how it sees the world, the way a person would. And so there's two main sensors. There's this sensor, which is stereo vision. The stereo vision looks out several meters, and that helps it find good footholds, avoid obstacles, things like that. And this LiDAR is basically a laser rangefinder. It's got 32 laser rangefinders that spin around and give you about 1 million points per second of where the world is around it. So this one looks further out, and this will help you find walls and other obstacles and things like that so you can navigate through them. Each one of these joints actually has a position sensor and a force sensor, especially the ones down in the legs. Plus, we've got a gyroscope in the pelvis. And so with all those sensors, we're kind of always sensing how we're falling. So that's the key part, right? You actually have to know how fast am I going, where am I going, to figure out where to put down that next foot. So these sensors help us find basically no-go regions. We call them no-step regions, obstacles, so that I can still maintain my balance even as I'm working my way through, you know, tougher terrain, like up a staircase or through a hallway.
So just like a human, then?
It's getting there.
Yeah.
That's the goal.
Incredible.
To enable Atlas to walk like humans, Kevin and the team focused on the robot's strength-to-weight ratio.
If you look at this upper leg here, I can grab a version of this that's cut open so you can see the inside. Totally redesigned the leg to use 3D printed aluminum. So what used to take dozens of pieces, we can now print out of one piece of aluminum. That's allowed us to make a leg that's about the same strength as the big robots, but at about half the weight.
Wow, it is actually really light.
Yeah, it's probably a similar weight to your upper leg.
Really?
Yeah.
I'd love to see what it's like inside, you know, when it's got all of the other bits.
Yeah. This is Aaron Saunders. He's our vice president
Hi,
of
Aaron.
hardware. He also led the design team for the Atlas robot, so he can tell you more about the leg.
So one of the most important things about this leg is that buried in it are hydraulic components. Underneath this cover on the leg is a series of hydraulic valves. And these hydraulic valves take the high-pressure fluid that's generated in the upper body, and they redirect it into the actuators that make the joints move. So the hydraulics is kind of like the muscles for the robot, and the valves are what controls those muscles. And you can see all these colored channels here represent little veins where the fluid routes through the leg.
So that's quite like the human anatomy.
There's a lot of similarities in how it looks, and the way the fluids move around the robot have a lot of overlap with how we would move fluids around our body.
Yeah.
Many of their robots are inspired by animals. The limitations of human form have been removed. Big Dog, their very first robot, was designed for the military, carrying a heavy payload through terrain that vehicles find impossible. And this is their latest creation. A hybrid robot with legs and wheels. Top speed 9 miles per hour, range 15 miles.
This is Atlas's cousin, Handle.
Wow. You can see that there are some similarities with Atlas. I mean, this looks similar. This sort of looks similar.
Yeah, it's a great observation. The upper body is actually borrowed from Atlas, so the arms and the torso are basically the same. You'll see the arms. Here, we actually mount them to the pelvis. And that looks kind of funny, but it allows us to do some interesting things. So now this big torso is actually free to move back and forth and plays a real critical element for balance. So if you think about when you're trying to stand still and someone gives you a little shove, if you don't want to step, you'll do a lot with your upper body to maintain balance. And Handle does the same thing, but it can do that without its arms moving around, right? So its arms are still down in the pelvis. They could be doing manipulation while the upper body's moving around to help with balance.
Great, so it still maintains its ability to do something in application whilst maintaining its balance.
Yeah, but the lower body is entirely new. We basically took off the constraints of a human form and said, well, you know, what if we open ourselves up to a human, but plus some machine things like wheels? You don't see spinning wheels in Mother Nature, but there's no reason we couldn't add a wheel to a leg and get the best of both worlds. It's far more stable and far more efficient than the legged things we've done in the past.
So it's more stable, more efficient.
And it's less complex, yeah, so that's a big advantage.
Yeah, that's really good.
We think it actually has a lot of potential because it has a long battery life. It's very stable, it's fast, so you can think about it working at a rapid rate.
It seems like Handle is trying to tell us something with that noise. What is it?
Yeah, what you're hearing right now is the hydraulic pump.
Okay, so we'll just carry on doing that while it's stationary.
Yeah, yeah. And that's a fan, of course.
It's certainly seen some action.
Yeah, yeah. It's funny, that's kind of true with all of our robots. You know, we have a mentality where we don't take it easy on the robots. We don't have a problem with pushing them to the edge to see how stable they are and how they're able to react to the real world. The real world isn't a perfect laboratory where, everything goes as planned.
Do you ever feel like sorry for Handle? When you give it a good push, do you feel sorry for it?
It's funny, we certainly get that reaction from people sometimes. When you design these things from the ground up and all of the mechanical pieces and the software, it's a machine. So even though it can look, especially for Atlas or Spot, like a person or an animal, there's no emotions here. It's all robotics, it's all hardware. And I certainly don't feel bad if I slap my toaster around a little bit either. So.
Yeah. Give your washing machine door a good shove.
Yeah, that's right. Sorry. That's right. Yeah, I don't have to go confess after that.
Yeah. I have seen some amazing machines here. two-legged humanoid robots, four-legged robots that look like animals. Their latest incarnation combines biology with technology, mixing and matching animals, humans, our own inventions, the wheel. This may seem unnatural, but once you've seen it all, it makes complete sense.
We're only beginning to understand the potential of this emerging species. Building robots that mimic humans continues to spark the imagination. But now, robots have adaptations that follow a very different evolutionary track. With mutant hands and hybrid limbs.
For me, it's been a revelation to understand the origins of our relationship with robots, and even why some people really do fear them. There is no doubt they have restructured the jobs market, and this will continue. But the biggest thing has been how fast robots are developing. We need to engage in this fascinating phenomenon to make sure that we have the choice over what we want robots to do for all of us.
And for me, I'm really surprised by what I've discovered.
So I've spent a little bit of time with robots now, and yes, I've seen that, okay, they're not quite as terrifying or as threatening as I maybe first thought. But that will change. In the next few years, physically at least, they'll be able to outcompete us in many of the things that we can do. But for me, the real problem isn't if they move like us or even look like us. The real issue will come is if they start to think like us.